You know, every single time you press play on a video, whether it's on YouTube or a movie streaming service, you're kicking off this incredible high-speed journey. A file that's just sitting on a computer somewhere in the world has to travel, sometimes thousands of miles, through the internet to land perfectly on your screen. So let's break down how that magic actually works.
I mean, seriously, think about that for a second. How does a massive video file manage to cross oceans and continents almost instantly, without all that annoying buffering? Well, that's the core question we're going to unravel in this explainer. It's a really cool story of physics, some very clever engineering, and a global network you use every single day, probably without even thinking about it.
All right, so to really get the solution, we've got to understand the problem first. Let's rewind and start with the absolute basics, the most fundamental way the internet works.
At its heart, the internet is built on this super simple idea, the client-server model. Your phone, your laptop, that's the client. It makes a request for something, like a video. And somewhere out there, a big, powerful computer is the server. It holds the files and, you guessed it, serves them back. Simple enough, right? Well, there's a catch, a pretty major flaw when you start dealing with a global audience.
And that catch, that big problem, it's just plain old distance. I mean, the speed of light is incredibly fast, but it's not instant. When a server is on a different continent, that physical gap creates a noticeable delay. In the tech world, we call that latency. And then if thousands of people are all trying to get the same video from that one server at the same time, you get a digital traffic jam or a bandwidth bottleneck. And what does that mean for you? The dreaded buffering wheel. Ugh.
So, if the problem is distance, what's the most straightforward solution? Well, you shorten the distance, right? So let's check out the first really clever shortcut engineers came up with to do just that.
And that brings us to the edge server. The idea here is genius in its simplicity. Instead of having just one giant server way over on the other side of the world, what if we put smaller servers right at the edge of the network, way, way closer to where people actually live? Now, these servers don't hold everything. They just store a temporary copy, what we call a cache, of the most popular content.
You know, the best way to wrap your head around this is with the pizza analogy. It's perfect. A single central server, that's like having just one pizza shop for the entire country. Imagine the delivery times. But edge servers, that's like opening a local pizza joint in every single town. All of a sudden, delivery is crazy fast for pretty much everyone.
But that brings up a really good question, right? How do you make sure that local copy, that cached file, isn't old and stale? Well, there are two main strategies for this. First, you've got time to live, or TTL. Think of it like an expiration date on a carton of milk. After a set amount of time, the edge server knows it needs to go check for a fresher copy. The other method is cache invalidation, or purging. This is more direct. It's like a product recall. The main server sends out a message saying, hey, everyone delete that old copy, I've got a new version. Both are super important for keeping everything up to date.
Okay, so these local edge servers are a fantastic idea. But what happens if you take that concept and scale it up, like way up? What if you build a massive, intelligent, global network out of them? Well, that's when things get really, really powerful.
And what you get is a content delivery network, or CDN. A CDN is basically just a giant worldwide system of those edge servers we've been talking about. They're all strategically placed in locations we call points of presence, or POPs. This right here is the invisible backbone that powers almost all the high-speed video and content you enjoy online. So here's how it all works in practice. When you click to watch a video, your request doesn't go all the way to the original server in, let's say, California. Nope. Instead, the CDN has this really smart DNS system that instantly figures out where you are and finds the closest POP to you. It might be in your city, or just a few towns over. And just like that, the video streams directly from that nearby server. It slashes the latency and gives you that smooth, instant playback we all expect.
And this isn't some abstract theory. This is a huge industry. You've got major players like AWS, Cloudflare, Fastly, and Akamai. They're the giants running this whole show. And they each have their own specialty. If you're building an app on Amazon Web Services, you'll probably use their CDN, CloudFront, because it's so tightly integrated. If you're a bank and security is your #1 priority, you might go with Cloudflare. Broadcasting a live sports event, you'd probably look at Fastly for its insane performance with live content. But at the end of the day, they're all solving the same problem, getting stuff to you fast.
All right, so we've got speed figured out. Our video's journey is now lightning fast. But there's another piece to this puzzle. How do we make sure that only the people who are supposed to see the video can actually watch it?
I mean, think about it. If you're a streaming service selling movies, what's to stop someone from paying once, grabbing the direct video link, and just posting it online for everyone to watch for free? How do you lock down premium content when it's literally sitting on public servers all over the world? The solution is something called a signed URL. The best way to think of this is like a special, single-use ticket to a concert, or a VIP pass. It's a totally unique link that's been cryptographically signed by the server. That signature is proof that you're allowed to watch, and the link itself is usually only good for a very short amount of time.
So how is this VIP pass actually created? Well, first, the backend server identifies which video file you're asking for. Step 2, it sets a very short expiration time. We're talking maybe just a few minutes. Step 3, using a secret key that only it knows, it generates a unique digital signature. And finally, it bundles all of that, the file path, the expiration time, and the signature, into a brand new, super long URL that it gives to your video player. That's how you get your ticket.
And here's a little pseudocode that shows what's happening under the hood. You see there's a policy that defines what asset you can access, the video file, and when it expires. Then, a signature is created using that policy and a secret private key. Finally, all of that gets combined into the final URL. When your player sends that URL to the CDN does the math all over again. If the signature doesn't match, or if that timestamp has expired, no video for you. Access denied. It's pretty slick.
Okay, we've nailed speed and we've nailed security. Now let's zoom out for a second and look at a couple of pro-level strategies that the really big streaming services, think Netflix, YouTube, use to manage these unbelievably massive systems. So, using one CDN is great, but what happens if that one provider has a bad day and goes down? For a huge company, that's a disaster. The solution is a multi-CDN strategy. The big players don't put all their eggs in one basket. They use 2 or even more different CDN providers and intelligently route their traffic between them. If one CDN has an outage in Europe, no problem. Traffic instantly gets rerouted through another. It gives them incredible reliability, what we call redundancy, and can even boost performance by picking the best network for any given user at any given time. And last but not least, one of the most valuable things these CDNs provide is data. A ton of it. Every single time someone requests a video, it creates a log. And these logs are an absolute goldmine for developers. You can see which videos are trending, where your viewers are located, how much bandwidth you're using, and maybe most importantly, you can track playback errors and buffering issues to constantly fine-tune and improve the experience for everyone.
So there you have it. From a super simple client-server request to this massive, globe-spanning, secure, and incredibly smart network. That is the journey of a video. It's this invisible superhighway that powers pretty much everything we do online, from our movie nights to live sports. The only question left is, as this network gets even faster and even smarter, what's it going to make possible next?